So we started introducing different interest rates, so now let's compare them. We talked about this simple rate being the quoted interest rate, and so that's the one that's going to be written into contracts and quoted by banks and brokers. The R-PER, that periodic rate, that's what we're going to use in calculations and show on the timeline. And then the EAR is used when we're comparing returns, especially when investments have different payment frequencies. So let's go through some examples. The simple quoted rate, remember we said it's stated in contracts, and so you also need to know, in addition to that quoted rate, what the compounding frequency is. So an example would be, you'd be told that the interest rate is 8% compounded quarterly, or 8% compounded daily. You need both pieces of information in order to be able to make use of it. Now that periodic rate, PER, is that simple quoted rate, because that's an annual rate, divided by that payment frequency or compounding frequency that you also need to know. So going back to the examples that we had before, 8% compounded quarterly would give you a periodic rate of 2%. 8% compounded daily, though, would give you a periodic rate of 0.02% because your periods are days. And then the effective annual rate is the annual rate that causes the present value to grow to the same future value as under multi-period compounding. It's basically what you're really earning on an investment, or what you're really paying on a loan. So here's an example. How do we find the EAR, the effective annual rate, for a simple rate of 10% if it's compounded semi-annually? So we know our result is going to be higher than 10%. So it's 1 plus 0.1 divided by 2, and that whole thing is squared minus 1. So we get an EAR of 10.25%. So now let's finish up by talking about amortized loans. An amortized loan is a loan that's repaid in equal installments or equal payments over its life. So sometimes we call this an installment loan. And so these are widely used for mortgages and auto loans, and so we've talked about that a little bit earlier. So what would happen is, for an amortized loan, you would create an amortization schedule that shows for every payment that the payments stay the same, and how much of that payment of each payment is going to interest and how much is going to principal, because over time those amounts change. In the beginning of the loan, more of the payment is allocated toward interest than principal, and then over time that shifts. You see a greater shift the longer the time frame of the loan. So here's an amortized loan of $15,000 at 8%. And there's going to be 3 equal payments. So what we need to do is figure out what those equal payments will be. And so we just go back to the financial calculator, plug in 3 for N, 8 for the interest rate, 15 for present value. Now that $15,000 is going to be positive because we received that as a loan. Future value will be 0 because we're going to pay this loan off by making those regular equal payments, and when we compute payment, we find out that the payment amount is $5,820.50. Now that's going to be negative because that's a payment that we are making, so it's a cash outflow. So here's what our complete amortization schedule looks like. First column is the balance at the beginning of that period, and then we have our payment, so notice that the payments stay the same. And then we show how much of that payment is applied toward interest and how much is applied toward principal. And then when we subtract this out, we get the balance. So we start with $15,000, we have a payment of $58,20.50, and then our interest rate is 8%, so we apply 8% on that beginning balance and we get $1,200. We subtract $1,200 from the payment, so the rest of that payment has to go to principal. And then our remaining balance will be the beginning balance minus how much we paid toward principal. And then we carry that number, the $10,379.50 from year 1, over to the beginning balance from year 2, and we just do the same thing.